A manual alarm system consists of break glass units and alarm sounders connected to a control panel and can only be activated by an individual operating a break glass unit after detecting a fire. People leaving a building because of a fire will normally leave by the way they entered. Consequently, break glass units are normally positioned at exits and story exits that people may reasonably be expected to use in case of fire, not just those designated as fire exits. They should be conspicuous, i.e. red, fitted at a height of about 1.4 metres or less for premises with a significant number of wheelchair users and not in an area likely to be obstructed. An automatic system adds fire detectors to the manual alarm system and is designed to raise the alarm to give early warning. Fire detectors are designed to detect one or more of the four characteristics of fire: heat, smoke, combustion gas such as carbon monoxide, and infrared or ultraviolet radiation. Information from a fire detector signal is sent to and processed by the fire alarm control panel. Fire detection systems are further classified according to the way the information is sent and processed as either conventional systems or addressable systems. Addressable systems are more advanced, providing more control and the ability to locate the individual detector that triggered the alarm. Conventional systems only identify the zone the fire has been detected in. In order to help determine where a fire has been detected, a schematic plan showing fire alarm zones in a multi-zone system adjacent to the control panel can be useful. British Standards specifies three categories of system: M for manual alarm system, L for life protection, and P for property protection. The emphasis of a Category L system is to ensure people are quickly and safely evacuated. This is a people out approach. Category P systems require an effective interface with fire extinguishing systems, as property protection is based on a fire out approach. Category L and P systems are subdivided further as shown. If for any reason your system fails, you must still ensure that people in your premises can be warned and escape safely. Temporary arrangements such as gongs, whistles or air horns combined with suitable training may be acceptable for a short period, pending system repairs. The fire warning sound level should be loud enough to alert everyone, taking into account background noise. In areas with high background noise or where people may be wearing hearing protectors, the audible warning should be supplemented, e.g. with visual alarms. Where people have hearing difficulties, particularly those who are profoundly deaf, then simply hearing the fire warning is likely to be the major difficulty. Among the most common solutions are visual beacons and vibrating devices or pages that are linked to the existing fire alarm. The fire detection and warning system should be supervised by a named responsible person, given enough authority and training to manage all aspects of the routine testing and scrutiny of the system. Control and indicating equipment should be checked at least every 24 hours to ensure there are no specific faults. All types of fire warning systems should be tested once a week. A break glass unit should be activated using a different call point for each successive test, usually by inserting a dedicated test key. This will check that the control equipment is capable of receiving a signal and in turn activating the warning alarms. Break glass units could be numbered to ensure they are sequentially tested. 6 monthly servicing and preventative maintenance should be carried out by a competent person with specialist knowledge of fire warning and automatic detection systems. This task is normally fulfilled by entering into a service contract with a specialist fire alarm company. The system should have a backup power supply capable of operating the system for a minimum period of 24 hours and sounding the alarm signal in all areas for 30 minutes.